Hello student, good morning. I am Dr.A.J. Sinha, Professor of Chemistry. Today I am going to discuss phosphorus, allotropic forms. Last class I have discussed nitric acid. Now I am going to discuss phosphorus. Phosphorus is found in many allotropic forms. The important one being white, red and black. White phosphorus. It is translucent, white waxy solid. It is poisonous, insoluble in water, but soluble in carbon disulfide, and glows in dark. That is called chemiluminescence. This question is asked. It glows in dark. That's why it is called, actually the process due to which it glows in dark, that is called chemiluminescence. Here actually it is excitation of electron. White phosphorus dissolves in boiling sodium hydroxide solution in an inert atmosphere, giving pH 3, that is called phosphine gas, a poisonous gas. Okay. P4 plus 3NOH plus 3H2O. It gives pH 3 plus 3NaH2PO2. pH 3 gas, how does it form? I told you. This is an important reaction. Again I am telling you. P4 plus 3NOH plus 3H2O. It gives pH 3 plus 3NaH2PO2. This is called sodium hypophosphite. Sodium hypophosphite. White phosphorus is less stable and therefore more reactive than the other solid phase under normal condition. White phosphorus is less stable. That's why it is more reactive than the other solid phases under normal condition because of angular strain in the P4 molecules. This is a reason I am telling you why it is more reactive. Then because of angular strain in the P4 molecules when the angles are only 60 degree, it readily catches the fire in the air. It readily catches the fire in air to give dense white fumes of P4O10. P2O5 phosphorus pentoxide is there. It is a dimer of P2O5, that is the P4O10. Then it's a structure. Its structure I am telling you. In the structure, molecules are in a strain. P4 molecules are in a strain because its angles are only 60 degree. It is in tension, strain. That's why it is more reactive. Okay. It readily catches fire in air to give dense white fumes of P4O10. Reaction you can understand. P4 plus 5O2. P4 plus 5O2. It gives P4O10. P4O10. Actually, this reaction takes place in the dark. It oxidizes actually in presence of oxygen, even in dark room. It oxidizes phosphorus, okay, and it will form a product P4O10. It consists of discrete tetrahedral P4 molecules. Actually, it's a structure you can understand very easily, very simple, that this is just like a tetrahedral structure only, and just 4 P are there, P, and all bonds are joined to each other. All P are joined to each other in a tetrahedral form. Okay, and angle is here type of tetrahedral, not 100%. Angle is 60 degree, but in tetrahedral say 109 that you know in methane CH4, but here that is a allotropic form is there, and P4 molecules have 60 degree angles. Bond angle is 60 degree, and all molecules are joined to each other by bonds. Okay, now actually you can tell this discrete tetrahedral, you can tell structure is it consists of discrete tetrahedral P4 molecules. Okay, now I want to tell you about red phosphorus. Red phosphorus is obtained by heating white phosphorus at 573 Kelvin in an inert atmosphere for several days. When red phosphorus is heated under high pressure, a series of phases of black phosphorus is formed. Now you understand here, when red phosphorus is heated under high pressure, a series of phases of black phosphorus is formed. Means from the red you are getting black phosphorus. Red phosphorus possesses iron gray luster. Red phosphorus possesses iron gray luster. It is odorless. No taste, no smell. It is odorless, non-poisonous, and insoluble in water. It is non-poisonous. And molecule in water. First, it is odorless, no smell, nothing. Second, non-poisonous. It is not poisonous, non-poisonous. And third, insoluble in water as well as in carbon disulfide. Chemically, red phosphorus is much more reactive than white phosphorus. Red phosphorus is much reactive. Red phosphorus is less reactive. Red phosphorus is much less reactive, very less reactive than white phosphorus. It does not glow in the dark. This is a very, very important things and difference also. Now this I have told about white phosphorus and red phosphorus. White phosphorus is poisonous, but red phosphorus is what? Red phosphorus is non-poisonous. Okay. Now I am going ahead. Red phosphorus structure is also same way. same way like a P4, but here now 3 P4 just are joined to each other. Its structure is just a P4. P4 are joined to each other. 3 P4 means 4 plus 4 plus 4. Total 8. 4 plus 4 plus 8. The total 12. 4 plus 4 8 plus 4 12. Okay. Then this P4 is joined with other P4 and other P4 is joined with third P4. Okay. And here you have to understand that when P4 are joining, then P and P, one molecule of P4 and other molecule of P4, both are joining by a single bond. Again, second and third are joining by a single bond. And other things are there, just like you can tell parallelogram. A structure is just like a parallelogram. That this things 2P in P4, 2P are parallel. 4P are there, then that 2P are, any 2P are just like a parallel. Okay, which is just like a parallelogram only. Then all 3 P4 molecules in that 2P are just all are joined by single bond only everywhere, but in each P4 2P are only 2P are joining with extra one bond, one extra. The total 5 bonds are there. All are joining with single bond. First and second and third is third and first. 4 bond, and one more bond is there. That is the front 2 P are joining. Then in each 3 P4 same type of structure is there. Only thing is that all 3 are joined to each other. Then this I told about the red phosphorus structure. It is polymeric. That's why it is called polymeric, due to this structure only. It is polymeric, consisting of chains of P4 tetrahedral linkage. This P, I am talking about the red phosphorus polymeric structure. Polymeric structure consisting of chains of P4 tetrahedra linked together. Okay, what I have discussed in that way. Now come to the black phosphorus. Black phosphorus has 2 forms: alpha black phosphorus and beta black phosphorus. Okay, black phosphorus has 2 forms. First, alpha black phosphorus, and second, beta black phosphorus. Alpha black phosphorus is formed when red phosphorus is heated in a sealed tube at 803 Kelvin. It can be sublimed in air and has opaque monoclinic or rhombohedral crystal. Okay, this you remember. Alpha, I am talking about alpha black phosphorus. Alpha black phosphorus is formed when red phosphorus is heated in a sealed tube at 803 Kelvin. It can be sublimed. Sublimation, direct without converting to liquid, it will go to the vapor phase. And that is called sublimation. Then this red for alpha I am talking about, alpha black phosphorus I am discussing. Then alpha black phosphorus is you can say sublimed or can be sublimed in air, okay, and has a opaque monoclinic structure, or rhombohedral crystal. It does not oxidize in air. White phosphorus was oxidizing, correct? But this alpha I can say black, it does not oxidize in air. Now come to the beta black phosphorus. Beta black phosphorus is prepared in heating white phosphorus. Alpha you got by heating red, but now beta black phosphorus is prepared in how you will get it. Then it is prepared by heating white phosphorus at 473 Kelvin. Alpha you got that time 803 Kelvin was required, and that also from red, but here 403 Kelvin is required, and that is from white phosphorus, okay, under high pressure. It does not burn in air. In air it will not burn up to 673 Kelvin, it will not burn, okay. It does not burn in air up to 673 Kelvin. This I have discussed about the allotropic form of phosphorus. Now I am going to discuss preparation of phosphine pH 3. Preparation of phosphine, this is a very important question, is always asked. How will you prepare phosphine? Then preparation I am talking about now. Phosphine is prepared by the reaction of calcium phosphide with water or dilute HCl. You remember it, how it is prepared? Then it is prepared by the reaction of calcium phosphide, not phosphite, PHIDE, calcium phosphide with water or with dilute HCl in any way. Then reaction how will you write that balanced equation I am telling you. Ca3P2, this is a calcium phosphide, Ca3P2 plus 6H2O. It will give calcium hydroxide 3CaOH2 plus 2pH3. We got pH3. Again reaction I am telling you, balanced reaction. Ca3P2, that is calcium phosphide, plus 6H2O. It gives 3CaOH2 plus 2pH3. Second reaction you can write, if HCl you are making from HCl, with use of HCl, then Ca3P2 plus 6HCl. Water, when water was there, that time 6 molecule. Here also 6 molecule. Okay, Ca3P2 plus 6HCl. Then here you will get calcium chloride 3CaCl2, again 2pH3. In both cases you got pH3. Then again I am telling you reaction, Ca3P2 plus 6HCl, it gives 3CaCl2 plus 2pH3. Now I am telling you laboratory preparation. In lab how will you prepare? In the laboratory, it is prepared by heating white phosphorus with concentrated NOH solution in an inert atmosphere of carbon dioxide. Okay, means carbon dioxide should be there. Inert atmosphere is required. Inert atmosphere of CO2. Then this reaction is very, very important, and always you keep in mind. Then reaction balanced equation I am telling you. Balanced reaction P4 plus 3NOH plus 3H2O. Correct? 3 reactants are there. First, white phosphorus, that is the P4, plus concentrated NOH, that we are adding here, 3NOH plus 3H2O. Okay, but atmosphere should be inert atmosphere of CO2. Don't forget. Then it will give two product. It will give PH3 plus 3NaH2PO2, means sodium hypophosphite. This is the Iitjee, phosphite, not phosphide. Here we are getting PO2. Okay, PO2, 3NaH2PO2, that is called sodium hypophosphite. This is the balanced equation reaction. When pure, it is non-inflammable. When pH3 is pure, when pure, it is non-inflammable but becomes inflammable owing to the presence of P2H4 or P4 vapors. It is actually non-inflammable, but as a impurities, it becomes this thing inflammable. In a pure stage, it is a non-inflammable. Question is asked, but becomes inflammable. From non-inflammable, it is becoming inflammable. From non-inflammable, it is becoming inflammable owing to the presence of P2H4 or P4 vapors. Okay. How will you purify? Because a P2H4 or P4 may be mixed. Then how will you purify? To purify it from the impurities, it is absorbed in Hi, hydrogen iodide, to form phosphonium iodide. Then it is not a new word, phosphonium, just like ammonium, NH4 plus, that is the ammonium ion. Same way, PH4 plus, that is the phosphonium. This is called phosphonium ion, similar to NH4 plus, ammonium ion, here PH4 plus, phosphonium ion, but here iodide, because reaction it is absorbed in Hi, then it will form just like ammonium iodide. Here phosphonium iodide, it will form phosphonium iodide, PH4I, which on treating with KOH gives off phosphine. Okay, means if you just purification I am talking about, it is purified from impurities. How? Then this it is absorbed. To purify it from the impurities, it is absorbed in Hi, hydrogen iodide, to form phosphonium iodide, which on treating with KOH gives off phosphine, means it will remove PH3. Okay, means reaction is PH4I plus KOH. It will give three products. First product is Ki plus H2O plus PH3, means PH3 is going outside. Now I am talking about this properties. It is a colorless gas with rotten fish smell. Correct? They say its smell is very bad, I mean rotten fish smell. Then many times you might have seen this type of a smell. Then always this type of a smell, rotten fish smell, is due to pH3. It is a colorless gas with rotten fish smell and is a highly poisonous gas. pH3 is a highly poisonous gas. And one more gas is there, that is a phosgene gas, COCl2. That is also deadly poisonous. Both are poisonous. It is highly poisonous, that is deadly poisonous. Then this I told you important properties. Now again further I am talking about. It explodes in contact with traces of oxidizing agents like HNO3, Cl2 and Br2 vapors. Means when pH3 will come in contact with traces of oxidizing agent like HNO3, like chlorine, bromine, that means they will come in contact with their vapors, HNO3, Cl2 and Br2 vapors, then it will explode. Explosion will take place. Further properties, it is soluble in water, slightly soluble, not too much. It is slightly soluble in water. The solution of pH3 in water is I told you it is slightly soluble in water. The solution of pH3 in water decomposes in presence of light, giving red phosphorus and hydrogen gas. This is an important reaction. Solution of pH3 in water decomposes. This pH3 will decompose in water in presence of light, and it will give red phosphorus and hydrogen gas. Okay, this is also production of red phosphorus we understood from pH3. When absorbed in copper sulfate, when pH3, next property is when absorbed in copper sulfate or mercury chloride solution, the means after that what you will get, then you will get phosphites. You will get corresponding phosphites. Now reaction I am telling you, 3CuSO4 plus 2pH3. 3CuSO4 plus 2pH3, it gives a phosphide. Two product it will give. First is the cupric phosphide, Cu3P2. Cupric phosphide. P2 means phosphide. Cu3P2. Cupric phosphide. Here you remember Cu3P2. Then that 2 is telling about copper valency. And Cu3, this 3 is telling about phosphorus valency. Then Cu3P2, that is the cupric phosphide, and second product is 3H2SO4, means sulfuric acid. Again I am telling you balanced reaction. 3CuSO4 plus 2PH3, it gives Cu3P2 plus 3H2SO4. Second reaction, that is the mercury chloride and PH3. If both will react, then it will give, now we will get this mercuric phosphide. That's why I told you corresponding phosphide. With copper it was giving cupric phosphide, and with mercury it is giving mercuric phosphide. Okay, then balanced equation I am telling you, 3HgCl2 plus 2PH3, it is giving two product. First product Hg3P2 plus 6HCl. When it reacted with copper sulfate, it has given H2SO4, cupric phosphide plus H2SO4. But here this mercury chloride is there, mercury chloride plus PH3, then obviously it will give HCl, 6HCl, hence product you will get Hg3P2, mercuric phosphide plus 6HCl. Now further reaction I am telling you, phosphine PH3. Phosphine is a weakly basic and like ammonia. Phosphine is a weakly basic, just like ammonia. Ammonia gas is basic due to lone pair of electron. This is also same way. Phosphine PH3 and NH3, similarity is there. It also has lone pair of electron. Ammonia also has lone pair of electron, nitrogen. Here phosphorus. Then phosphine is weakly basic and like ammonia gives phosphonium compounds with acids, because it is a basic, then obviously it will react with acids. Then PH3 plus HBr. HBr is acidic, has acidic property, just like HCl, it is HBr. It is also acid. Then PH3 plus HBr, it forms PH4Br. PH4, phosphonium bromide, just like NH3 plus HI. NH3 plus HI, NH4I, same way, PH3 plus HBr, then PH4 plus and Br is minus, then phosphonium bromide. Okay, this I have told the reaction properties of PH3. Now I will discuss application, usage of phosphine. The spontaneous combustion of phosphine is technically used in Holmes's signals. You must remember, question is asked, Holmes's signal. What is the Holmes signal? I am telling you. Understand, it is actually application. The spontaneous combustion of phosphine, actually it burns continuously phosphine gas. Then the spontaneous combustion of phosphine is technically used in Holmes signal. Containers containing calcium carbide and calcium phosphide are pierced and thrown in the sea. Remember it, again I am telling you, containers containing two things, calcium carbide and calcium phosphide, and these are kept in containers containing calcium carbide and calcium phosphides are pierced, 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 hole, little hole they are making, pierced and thrown in the sea. When the gases evolved, burnt and serve as a signal. in C, light it will give the light. Then that light is used as a signal for boats and any others, this steamer and any things are coming, any type of water, you don't know, so many things are boat in Delhi or boat and this steamer will be running, correct? Then for them it is used as a signal. It is also used in a smoke screens. It is also used in a smoke screen. Okay. Then this I have discussed about application. Now I am going to discuss some compound of phosphorus. As for example, phosphorus trichloride, PCl3. Okay, I will tell about the this compound, phosphorus trichloride. Phosphorus actually forms two types of halide, PX3. X may be fluorine, chlorine, bromine, iodine. PX3. X is equal to F, maybe Cl, maybe Br, maybe I. And other halide is PX3. PX3 and other is PX5, means PCl3, PCl5. Then here PX5, then X may be again fluorine, chlorine, bromine, not iodine. Only 3. X is equal to F, Cl and Br. And now I am telling about this phosphorus trichloride, PCl3. Then how it is prepared? First preparation, you see, it is obtained by passing, you can say, chlorine over heated white phosphorus. Okay, it is obtained by passing chlorine gas over heated white phosphorus, means P4 plus 6Cl2. P4 plus 6Cl2. It will give only one product, that is the PCl3, means 4PCl3. P4 plus 6Cl2. Only one product is there, then obviously P4 is there, then 4PCl3 will form, that is confirmed 4PCl3. It is a balanced. 6Cl2 means 12 chlorine, and here 4PCl3 means 12. It is balanced. Then P4 plus 6Cl2, it will give 4PCl3. Now more about the PCl3. It is also obtained, next preparation I am talking about, it is also obtained by the action of thionyl chloride with white phosphorus, means P4 plus 8SOCl2, SOCl2. It is called thionyl chloride. Don't forget, SOCl2 is called thionyl chloride. Thio means sulfur. Then P4 plus 8SOCl2, it will give 3 product, 4PCl3 plus 4SO2 plus 2S2Cl2, 2S2Cl2, correct? Then again I am telling you reaction, P4 plus 8SOCl2, thionyl chloride. Then you will get 3 product, 4PCl3 plus 4SO2 plus 2S2Cl2, okay. Then is sulfur chloride, that is the sulfur chloride, S2Cl2, disulfur dichloride, or simply sulfur chloride. This I have discussed about the preparation. Actually, these reactions are asked. All reactions are important. You can't ignore any. Now, I am going to discuss properties of carbon tetra. This properties of phosphorus trichloride. Then first property, physical property, it is a colorless, oily liquid. Okay, this is a liquid actually. Phosphorus trichloride is liquid, oily liquid. It is a colorless, oily liquid, and it is a liquid, oily liquid, and it will hydrolyze and hydrolyzes in presence of moisture. Hydrolyzes in presence of moisture means with water. Then PCl3 plus 3H2O, it will give H3PO3 plus 3HCl. Okay, PCl3 plus 3H2O, it gives two products. First H3PO3 and second 3HCl. Okay, then balanced equation is PCl3 plus 3H2O, it gives H3PO3 plus 3HCl. Now second reaction, second property, it reacts with organic compounds containing OH group such as acetic acid, ethyl alcohol, CH3COOH. Then you know CH3COH, COOH structure, CH3, C, upside you can write CO, O and C double bond. C and O double bond, and with other oxygen single bond. Okay, that is the OH. C is attached to oxygen with double bond, and C is also attached with OH. Then now it becomes COOH. Then OH group is present in acetic acid, and also ethyl alcohol already they have OH. Then reaction I am taking you that CH3COOH. CH3COOH means acetic acid plus PCl3. It will give two products. First, it will give acetyl chloride. Acetic acid, it is giving acetyl chloride. H will replace by Cl. Then it will give CH3COCl, acetyl chloride, and other product will be phosphoric acid, H3PO3. Okay, both products are very, very important, and reaction itself is very, very important. Question is asked. Then I am telling you now balanced reaction. 3CH3COOH means 3 molecules of acetic acid, 1 molecule of PCl3. It will give 3 molecules of acetyl chloride means 3CH3COCl plus 1 molecule of phosphoric acid, that is the H3PO3. Correct? Now second reaction with ethyl alcohol I am talking about. Same way, 3C2H5OH plus PCl3, it will give two products, ethyl chloride and phosphoric acid. Then means balanced reaction I am telling you, 3C2H5OH plus PCl3, it gives 3C2H5Cl plus H3PO3. In both cases you are getting phosphoric acid, and in both cases you are getting chloride. Acetyl chloride in the case of acetic acid, and ethyl chloride in case of ethyl alcohol. It has a pyramidal shape. Okay, pyramidal shape already I discussed, you know. It has a pyramidal shape in which phosphorus is sp3 hybridized. Here phosphorus is sp3 hybridized means sp3, total 4 orbitals will be there. correct, sp3, then total how much is coming, 1s and 3p, then it is becoming 4 sp3, then it is giving 4 orbitals. P gives 4 orbitals. That is, then that's why out of 4 orbitals 3 are attached with 3Cl, and fourth one orbital is have not bonded with chlorine. This is as a lone pair of electron. Phosphorus, just like ammonia, it has you have seen NH3, 3 bond was there, H with nitrogen, and one lone pair of electron was there. Here same way, P is making 3 bond, PCl, 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 one in the front, other in the back side, and the third one in the left side. Okay, and fourth one orbital is not bonded, lone pair electron is there. Okay, it can donate. And this I told you, this shape is called pyramidal shape. Don't forget, question is asked, what is the shape of PCl3? Then PCl3 has a pyramidal shape. Now I am telling about phosphorus pentachloride, PCl5, phosphorus pentachloride. Phosphorus pentachloride is prepared by reaction of white phosphorus with excess of dry chlorine. Chlorine must be dry. Then P4 plus 10Cl2. It gives 4PCl5, phosphorus pentachloride. P4 plus 10Cl2. Only one product directly will get PCl5. Then balanced equation is very easy to balance. P4 is there, then you will get 4PCl5. Now by balancing only one atom of phosphorus, other is automatically it will be balanced. Then it will come 10Cl2. Then P4 plus 10Cl2, we got 4PCl5. Cl5, 5 into 4, 20. Here also 10Cl2 was there, it was 20. Now second reaction I am telling you, preparation. It can also be prepared by the action of SO2Cl2. SO2Cl2 on phosphorus, white phosphorus. Then P4 plus 10 SO2Cl2. Okay, P4 plus 10 SO2Cl2. Then here you will get two product, 4PCl5. It is easy to balance also because only one product is there for phosphorus. Then it will be 4PCl5 and other product is 10SO2. Okay, this is called this sulfuryl chloride. Okay, SO2Cl2 is called sulfuryl chloride, and that time I discussed, that was the thionyl chloride, that was SOCl2, only one oxygen was there, SOCl2, but here two oxygen is there, SO2Cl2. This is called sulfuryl chloride. Now properties I am telling you. PCl5 is a yellowish white powder. It is solid. Actually, because it is the molecular weight is high, and high molecular weight means always it will be solid. Less molecular weight means liquid, and very less means maybe gas. Then PCl5 is heavy molecular weight. Then PCl5 is a yellowish white powder, and in moist air, means with water, it hydrolyzes to POCl3, phosphorus trichloride. Okay, phosphorus oxytrichloride, POCl3, and finally gets converted to phosphoric acid. In two-step reaction will take place. PCl5 plus H2O, it gives POCl3, phosphorus oxytrichloride, or directly contain phosphorus oxychloride. This is the main product. Other product is HCl. Then balanced equation is PCl3 not PCl5 plus H2O, it gives POCl3 plus 2HCl. Now this POCl3 will react with, further it will react with water, and it will give H3PO4 plus HCl. Balanced equation is POCl3 plus 3H2O. Now it will give two products. First product is H3PO4 and other product is HCl. Okay. Then this I have told you about the properties. Okay. Now further properties I am telling you. When heated, it sublimes but decomposes on a stronger heating. Means if you will heat PCl5, then it will break into two parts, PCl3 plus Cl2. Okay, when heated, it sublimes but decomposes on a stronger heating. PCl5 will break into PCl3 plus Cl2. Now next reaction I am telling you, next property, it reacts with organic compounds containing OH groups, OH bond. Okay, like previous I discussed same type of reaction containing it will give chloro derivatives. When it will react with organic compound containing OH group, it will convert, that compound will be converted into chloro derivatives. Example I am telling you, reaction I am telling you, C2H5OH. This compound has OH group plus PCl3. Then now see this C2H5OH plus PCl3, it will give derivative. Then what are the derivatives? Means two chloride you will get here after the reaction. First product is ethyl chloride, C2H5Cl, and other will be POCl3, phosphorus oxychloride, and third is HCl. In everywhere Cl is attached. That's why it is called chloro derivatives. Okay. When it will react with organic compounds containing OH, it will convert them to chloro derivatives. Now all are chloride. C2H5 plus C2H5OH plus PCl5. It gives three chloride. First C2H5Cl, other POCl3, and third is HCl. Same way acetic acid, CH3COOH plus PCl5. Again it will give three chloride. First CH3COCl, this reaction you know. Extra thing is again POCl3, and third is HCl. Then this is also chloro derivatives. One more time I am telling the reaction, CH3COOH plus PCl5. Three products are there, means three chlorides are there. First CH3COCl, second POCl3, and third HCl. Okay, I told you. And other reaction again I am telling you, other properties. Finely divided metals on heating with PCl5 gives corresponding chlorides. Means reaction with metal. Reaction is very easy. 2Ag plus PCl5, 2Ag silver, 2Ag plus PCl5, it gives two product, 2AgCl plus PCl3. 2Ag plus PCl5, it gives two product, 2AgCl plus PCl3. And other reaction, that is with stannous, tin, Sn plus PCl5, SN plus 2 PCl5. It gives two product. Both are chloride. In our above reaction also, what I told you, chloride was there. 2Ag plus PCl5, 2AgCl plus PCl3. Here again same way. SN plus 2 PCl5. It gives SnCl4 plus 2 PCl3. Now application use I am telling you, it is used in the synthesis of some organic compounds, as for example ethyl chloride, acetyl chloride, etc. In gaseous and liquid phases, it has a trigonal bipyramidal structure. Don't forget, PCP question is asked many times. Question has been asked, what is the structure of PCl5? This is bipyramidal structure, trigonal bipyramidal structure. Then here you should understand very easily, phosphorus is there, then 5 bond will be there, 5 chlorine are there, then 2 chlorine will be just like they will join at 180 degree. Okay, 180 degree straight away, 2 Cl, and rest 3 they will make a trigonal. Correct, 3 chlorine is left, they will make a trigonal shape. And this bipyramidal, because 2 chlorine atoms are that in a straight line, and 3 chlorine atoms are making a triangle. Okay, then a straight this straight line they are making, P is attached with 2 chlorine atoms in a straight way. Then P and Cl bond length is 240 picometer, and when they are making in a triangle form, then that time P and Cl bond is 202 picometer. Okay, this bond length I told you, that is a straight line what is making, that is also called axial, and 3 they are making a triangle that is called 3 equatorial. Okay, the 3 equatorial, you can say phosphorus chlorine bonds are equivalent, all 3 bonds are equal, not 100% equal, equivalent, while the 2 axial bonds, that is axial bonds means here just like a straight line I am telling you, a straight line 180 degree, then 2 it will form 2 different type of form. First, 3 equatorial bonds, 3 chlorines are making bond, all are equivalent, then 3 bonds are there, all 3 bonds are one type of bond, that's why it's called 3 equatorial bonds are, that is called equatorial bond, equatorial triangle form, equatorial bonds question is asked, and are equivalent, while the 2 axial bonds are longer than equatorial bonds, that's why its bond length is more. This is why it happens 2 type of length. This is due to the fact that the axial bond pairs suffer more repulsion, then that's why they are far, they are very far. Almost I am taking you a straight line because of repulsion, they want to make a distance, that they are far, and it became like that, just like a straight. Then axial bonds pairs suffer more repulsion as compared to equatorial bond pairs. Okay, that's why they are making triangular, but here 2 bonds ClCr repulsion is more, that is a axial, in axial more repulsion, equatorial less. Reason I told you, this is due to the fact that the axial bond pair suffers more repulsion as compared to equatorial bond pair. In the solid state, this happens only in the gaseous and liquid phase, but in solid state In the solid state, it exists as an ionic solid. Ionic solid. What is the cation and what is the anion? Then PCl4 plus. This is the cation PCl4, 1 plus is there, and anion PCl6, 1 negative. PCl6, 1 negative. This is the anion, and PCl4, that 1 plus, that is the cation. That's why this is actually salt. It is called ionic salt. Then in the solid state, it exists as an ionic solid. PCl4, 1 plus, that is the cation, and PCl6, 1 minus, that is the anion. In which in this PCl4, 1 plus is cation. This is actually tetrahedral, and the anion PCl6, 1 minus, this is the octahedral. Okay. Then now I have finished this PCl3 and PCl5 I have discussed. Okay. Now I am stopping only here. Next class I will discuss oxo acids of phosphorus. Oxo acids of phosphorus. Thank you.